we have studied so far has one rectifier and one inverter. So, there are two converters. So, these are known as two terminal DC systems. That is a system with two converters, one acting as a rectifier, another acting as an inverter. Okay. Now, there are some situations where having more than two will be advantageous. So, such systems are known as multi-terminal DC systems. This is abbreviated as MTDC. So, in multi-terminal DC systems, there are more than two converters, and at least one of them operates as a rectifier and at least one of them operates as an inverter. So, at least one converter operates as a rectifier and at least one converter operates as an inverter. So, what are these multi-terminal DC systems and where do they find applications? So, it is better to start with applications so that one can get an idea of the arrangement that is used in a MTDC system. Now, if you recall the applications of two terminal systems, we have already seen some applications. Say, if there is a bulk power that needs to be transmitted across a long distance, then DC is an option for economical reasons. And there are some other reasons. For example, if there are two systems operating at different frequency and you want to interconnect them, then HVDC is an option. Or though they are operating at the same nominal frequency, the frequency control has to be independent, means that they can be connected using DC. And there are a few other applications, for example, underwater or underground transmission, you use DC. Now, similarly, there are applications for multi-terminal DC systems. So, first let us see the applications, then it becomes clear why we need this and what exactly is MTDC system. Okay. The first application is bulk power transmission from several remote generating stations. To several load centers. Now, this application is similar to the application for the two terminal system. Say, in two terminal system, if I have one generating station which is far away from the load center, then HVDC is an option. Okay. Now, here instead of one generating station and one load center, there are several generating stations and several load centers. So, for example, I have at some location a generator. All of you are familiar with single line diagram, right? So, if I have a generator, so I will not show several, say two, more than one. So, suppose there are two generating stations and say two load centers. Now, what one can do is use a MTDC system. Say, suppose I wanted, okay, let me first try to say how different is MTDC system from two terminal DC systems. Suppose I had two terminal DC systems, then I can have a two terminal DC system between, say, let me call this bus 1, bus 2, bus 3, bus 4. Okay. So, I can have a two terminals DC system from between 1 and 2, between 3 and 4, but the point is we need some interconnection because of reliability, and it is not that the load at 2 is exactly matching the generation at 1 and the load at 4 may not be exactly matching the. So, somehow the loads at 2 and 4 are met by 1 and 3, generators at 1 and 3. So, we do an interconnection. Now, for the sake of reliability, we may have a mesh connection. So, when I say mesh connection, what I mean is I may have a connection between 1 and 2, 3 and 4, and also between 1 and 3, and I may also do between 2 and 4 for reliability. Suppose there is loss of one line, I can still. Now, if I have 4 such two terminal systems, how many converters are required? Say I want to connect 1 and 2, 3 and 4, 1 and 3 and 2 and 4. All these buses are connected by two terminal DC systems. 8. I need 8 converters. I need 8 converters. Now, what we do in MTDC system is we do not use 8 converters. For the same connection between the buses, we will need less number of converters. Let us see how it is done. So, these are schematic diagrams for the converter. So, since I have shown the generators at 1 and 3, it means that if I just connect 1 and 2 and 3 and 4, it means the converter at 1 is operating as rectifier, converter 2 at bus 2 is operating as converter at 1 is operating as rectifier and converter at 2 is operating as inverter. Okay. The loads are again AC. Please note, loads are the usual AC loads. Now, let us say how to do an interconnection such that the number of converters that is required is shown to be just 4, and this is less than 8, which was required for making the same amount of connections using two terminal DC systems. So, the DC side will have 2 wires. I show the 2 wires, positive and negative. Now, this is the arrangement. So, you see that there are 4 transmission lines, assuming that all these buses 1, 2, 3, 4 are far away. Okay. Suppose the distance between any 2 buses among these 1, 2, 3, 4 are a few hundred kilometers. Now, one can see that there are only 4 converters and 4 DC transmission lines. Okay. Now, if you had 2 terminal systems, you will still have 4, I mean for the same amount of, for the same connections, you will still have 4 transmission lines, DC transmission lines, but 8 converters. Are you getting the point or not? See, what I am trying to say is, if you look at the converter connected to bus 1, the DC side has connections to two converters. One is connected to converter at bus 2, other is converted to converter at bus 3. Okay, there are two wires going from the DC side of the converter at bus 1. Okay, so in the case of two terminal systems, on the DC side you will have only one connection. You will have only one connection. So each converter on the DC side is connected to just one more converter on the other end of the transmission line. Whereas here there can be multiple transmission lines connected on the DC side. So in this case, we need what is known as in general when it comes to MTDC systems, breakers are generally required, circuit breakers. Circuit breakers are generally required. Now, that raises another question, whether it was required for two terminal systems. See, what I am trying to say is, circuit breakers are generally required for multi-terminal DC systems. Yeah. See, when do we need circuit breaker? Protection. If there is a fault somewhere, we want to isolate only the faulty component. Suppose the fault occurs on one of the 4 transmission lines. There are 4 DC transmission lines. Suppose there is a fault. To isolate, you have to just to isolate the fault, you have to isolate the entire transmission line without affecting the rest of the system. That's what you do in a normal AC system. Now, if you have only 2 terminal links, can I do away with the circuit breakers? Yeah, say I don't have multi-terminal, suppose I have just a 2-terminal. Yes. Or in this case 4 2-terminal systems. Instead of one MTDC system, I can still have for the same connection required 4 2-terminal systems. So wherever if at all there is a fault somewhere in the system on the transmission line, can I avoid circuit breakers? Yeah, see, the point is you have control over the thyristors. So you can always have control over the thyristors and see that there is no current. You can completely block the current. Okay. Now that is, if you do like that here, what happens? You are not actually isolating only the faulty component, you are actually affecting the other parts of the system. So when you have a MTDC system, breaker is a must. Okay. So breakers are generally required for MTDC systems, but it's okay to not have a breaker for a 2-terminal DC system. So this is one application. Let us look at some more applications. The second application is asynchronous interconnection. Between adjacent power systems. Now we say there is an asynchronous interconnection if there are 2 or more systems operating at different frequencies, not necessarily different nominal frequencies. The nominal frequencies can still be same. Now this comes into picture, that is when 2 or more AC systems operating at different frequencies. So when I say different frequencies, it means not necessarily different nominal frequencies. It can be same nominal frequency. So such systems are to be interconnected. So this application is again similar to the application of a 2-terminal system, but only difference is in the case of 2-terminal it was just 2 systems. Now we have in general any number of systems. So let me take an example. Suppose I have 3 systems. Okay. So these are 3 AC systems. AC system 1, AC system 2, AC system 3. So what one can do is do an asynchronous interconnection. So have a converter connected to each of these 3 systems. Compare this with interconnecting system 1 and 2 using two terminal system. Similarly, interconnection between 2 and 3, AC system 2 and AC system 3 by 2 terminal. Again between 1 and 3 using 2 terminal. So this is another example as well as application. So we are, I mean, I am not trying to give a definition or a general definition of MTDC system. I am trying to convey what is MTDC system by means of applications. So this is one application. So similarly, there are a few more, there is one more application. Okay. Reinforcing a heavily loaded AC network. Okay. So let me first say what I mean. Suppose I have a large AC network. Large means it occupies a large geographical area, AC network. Essentially, it contains load. Now, there is a generator somewhere which is say remote. Now, I use an arrangement like this. I have one converter here. Now, in the AC network, I use more than one converter as inverters. Okay, let me first complete the diagram and try to convey what I mean. So, I have one AC bus to which a rectifier is connected. So, this converter operates as a rectifier and the remaining 3 converters operate as inverter. This is inverter, this is an inverter, this is also an inverter. So, whenever we have an AC network which is distributed over a large geographical area, now that is a very common. Suppose I have a big city, that means a large urban area. That means it is distributed. The network is distributed over a very large geographical area. Now, in that case, if I inject power at one point, what will happen? See, suppose the network is huge in area. Okay. So, if I inject power at one point, now suppose I inject power at this point. Okay. Now, if that same power which is injected has to get distributed over the entire AC network. So, if it has to go to the other end, say at this point, it has to pass through all the wires that are interconnecting this end and the other end to which the inverter is connected. So, just for transferring the power here, these wires have to carry a large amount of current. So, it is actually loading the AC network. Now, many times it is advantageous to spend on the converters, additional converters which act as inverters instead of spending on the wires. So, it is actually ensuring that the AC network is not loaded to carry unnecessarily power from one end to the other end. Instead of that, inject power at many points. Okay, many times this is less expensive. So, it would be advantageous to inject power at more than one point, so that the AC network is not overloaded. So, this arrangement requires one rectifier and many inverters, only one rectifier and many inverters. Now, these are some applications. In the process, we saw examples as well. Okay. Now, still now I have not given a very proper definition of MPDC system. So, one can say that a MPDC system consists of more than 2 converters and there is an interconnection on the DC side. That's the definition. Okay. So, there is an interconnection on the DC side.